Hi folks, really happy to be here at GitKon with you today. Real quick introduction, my name is Edward Thomson. I'm a product manager at GitHub. I'm the maintainer of the libgit2 project, which is a sort of library that you can use in your application if you want to talk to Git repositories. And before I became a product manager, I was an engineer. I've actually been working on version control tools for a really long time. I've built version control systems at GitHub, at Microsoft, and a little company called SourceGear. I've been working on version control tools since the year 5 BG. When I say BG, I mean before Git. And why do I think about version control tools in terms of Git and its history? Well, because Git is the dominant version control system. If there was a version control war, Git won it. And so when I say 5VG, I'm looking at about 21 years of history in the version control space. So I've worked on Git and tools around Git, but I've also worked on Team Foundation version control, a tool called Source Offsite, a tool called Vault, CVS. If you are an old person like I am, you might remember CVS. And so before the rise of Git, we had a real diversity of version control systems. It wasn't a given that you would use one thing. CVS was popular, Subversion was popular in its time, but it wasn't dominant the way Git is. So why did Git become popular? Well, I'm going to borrow a term from Richard Gabriel, and I'm going to say that Git won because worse is better. Now, that's a little bit rude and a little bit tongue-in-cheek, but why don't I take you through what it means to be worse is better? Well, like I said, this was coined by Richard Gabriel. Richard Gabriel was the founder of a company called Lucid, and he worked on a technology called Lisp. It's a language, it's a set of computers that run this language, and when asked why C, the C language, and Unix, the Unix operating system, were winning, if you will, in terms of competition with Lisp, Richard thought about it and said, kind of tongue-in-cheek, well, because worse is better. And he actually went on to give a talk at a Lisp conference and write a paper to follow it up called Lisp, Good News, Bad News, How to Win Big, where he went on to define this worse is better philosophy. So it actually went from a tongue-in-cheek statement to a real idea. And the worse is better philosophy sets out 4 points that a piece of technology needs to hit in order to fall into the worse is better camp. First of all, it needs to have simplicity. Second of all, it needs to have correctness. Third, consistency. And fourth, completeness. Now, these all sound like good things, don't they? How is this a philosophy where worse is better? Well, we have to contrast worse is better with the right thing approach. Sometimes when you build software, you really want to focus on doing the right thing. Now, the right thing philosophy has these 4 same tenets: simplicity, correctness, consistency, and completeness. So they actually might differ in some more fundamental ways, right? So the worse is better philosophy and the right thing philosophy have the same tenets. Sometimes the right thing philosophy is called the MIT philosophy, MIT, the Massachusetts Institute of Technology. But we'll talk about that more in a second. Now, how do these 2 philosophies differ? Well, let's look a little bit more at the right thing philosophy. Doing the right thing means that when you look at the design of a system and you look at its simplicity, then the design must be simple both in terms of its implementation, so the code must be simple, and in terms of its interface. It must be simple to use. Users should find using the system simple. That seems like a great tenet. In fact, that's the most important tenet. It's more important than the interface of the system to be simple than its implementation. Okay. Next, it must be correct. Incorrectness is not allowed. You should have a bug-free program. Sounds good. Next, it must be consistent. And in fact, consistency is even more important than interface simplicity. Like we can cut a few corners in the simplicity area as long as it's consistent along the way. And finally, it must be complete. It must, be usable and do all the things that a user would expect it to do. Okay. These all sound like great tenets. Well, how does the worse is better philosophy compare with these? Well, again, simplicity is at the core of the worse is better philosophy. It's the first point. But there's a bit of a twist. Instead of focusing on the user interface being simple, it's more important that the implementation is simple. The code must be simple to understand and to extend, but it doesn't necessarily have to be simple to use. It should be. It's not quite as important. Next, correctness. Yes, the design should be correct in all observable aspects, but it's actually slightly better to be simple than correct. And of course, when we say simple, we're really talking about the implementation, not the user interface. Next, the design should be consistent. But it's actually better to draft the parts of the design that deal with less common circumstances than to introduce complexity or inconsistency in the application. So again, simplicity wins. Simplicity of implementation. And finally, completeness. And completeness is of course important, but it could be sacrificed whenever implementation simplicity is jeopardized. So really, the core of worse is better is building simple, extendable code. Not necessarily code that's great to use, not necessarily code that's consistent, not even code that's necessarily complete, just code that's simple. Now, of course, this is a bit of a straw man, and he did develop this sort of tongue-in-cheek, but as he was building this philosophy and thinking about it, he realized that actually software built with the worse is better philosophy has better survival characteristics than when you build software to do the right thing. That's why C and Unix won against Lisp. Because, well, it shipped. At GitHub, we talk about shipping being a feature. It's very important to get code out the door, right? We talk about minimum viable products over the last many years. That's a term of art that I don't think was in use when Richard Gabriel wrote his paper. But now we actually do think about the idea of building a piece of software, even though it's not complete, and getting it out the door so that we can iterate on it and people can start using it. I think it's incredibly important not to underestimate the fact that actually just getting software in people's hands is perhaps the first and most important step of developing any system. Now, I think that there's actually one person who adheres to the worse is better philosophy and understands this perhaps better than any other software engineer that I can think of. That person is Linus Torvalds. If you're not familiar with Linus Torvalds, he built the Linux kernel, and when he got bored with that one day, he decided to go build the Git version control system. And I think that those are two excellent examples of the worse is better philosophy in practice. And again, this is a bit tongue-in-cheek, but it's also very important to why these two systems have been as successful as they are. Now, the first time anybody heard of the Linux operating system was way back in 1991, where a young student named Linus Torvalds posted on a Minix mailing list. Minix was a somewhat Unix-like operating system that ran on small PCs back in the late 80s and early 90s. Now, Linus had gotten a 386 computer and was trying to learn how to basically program it at a very deep, low level, right? He was trying to understand how the bootloader works and how to build an operating system on the 386 chip. And that's actually, the 386 has a lot more capabilities than earlier processors, and so he was able to, or envisioned that he could do things that Minix couldn't do. And so he started playing around with this early operating system. Now, one of the interesting things in this early announcement that he was playing with building a kernel was that he noted that it will never be the kind of professional operating system that Herd will be in the next century or so. Well, in fact, it turns out that the Linux kernel was incredibly popular. It took off. It really filled a need that a lot of hobbyists had. I was an early Linux user, and we had these relatively powerful computers, and we were still using maybe MS-DOS on them, or early versions of Windows, like Windows 3. Now, there were ways that you could extend that with tools like Desk View and QEMM, if you remember those days, and you could do some sort of multitasking on these systems. But there was really a need for something more advanced, like a Unix system could offer. This was really the first PC that could capably run Unix, and Linux really was a need that was. Linux really filled a need that we didn't realize that we even had. And so, of course, Linux became very popular. And people built distributions on top of this. Linux is the kernel itself and the distribution sometimes you'll hear it referred to. So that's what we call the user space code, things like your shell. You know, you interact with Bash on a Linux system or ZSH or TCSH, and you don't really interact with the Linux kernel itself. And so some people have taken to calling a Linux system GNU Linux. The idea here is that the GNU project, which spun out of the Free Software Foundation and intended to build a set of user space tools, compilers, developer tools, shell. When you run ls, that's a GNU tool. And to build these for a Unix-like system. And GNU actually had envisioned its own Unix-like system complete with a kernel. That's Herd, that Linus had referred to earlier. But it was slipping, as he noted. It might come in the next century or so. So some people took to calling a Linux system a GNU Linux system because it used a Linux kernel, but it used a lot of GNU user space tools. So what happens when we think about GNU Linux versus GNU Herd, the complete GNU system with that mythical kernel? Well, that mythical kernel never really materialized. It kind of got developed in fits and starts, but even now it's only at version 0.9. They've never seen a 1.0 of Herd. Now, why is that? Well, remember when the do the right thing approach to software development was also known as the MIT style? Well, it turns out GNU and the Free Software Foundation came out of MIT. Herd is an incredible architecture of microservices and very clever operating system ideas that were developed in the 90s and implemented in the 90s and into the 2000s and 2010s. Herd never really materialized. Why not? Because they were so focused on the architecture and getting that right that they never really got the code out the door, if I'm blunt about the problem. Whereas Linux, with its worse is better approach, where Linus just announced a thing that he was building, even though it was hardly operational at the time. When he first announced it, it was very early days. It was not something that you could use. It was something that you could tinker with, that you could be a hobbyist about and develop yourself. But it was not something that you could use. Certainly it was not something that you could put on a phone or put in a server room and actually operate anything. No. But he made that announcement early. He released it on an FTP server early and allowed people to start using it. Now, one of the interesting things about the Linux kernel is that it was developed in a collaborative environment. It's an open source project. In fact, it's probably the most successful open source project that the world has ever seen. And the way that the open source project worked was on a mailing list. Much like Linus went and announced on a news group that he was doing this, the actual development of the kernel itself took place on what's called the Linux kernel mailing list, where people exchange patches. When Phil Oster here says, here's a change to the make file so that we can better support machines without the Pentium 4, without the Athlon chip. This is an older patch. This is from way back in 2002. He writes the code on his local machine. He runs the diff command, and then he sends the output to the mailing list. And if Linus or whomever is the maintainer of the subsystem of the kernel is interested in this change, and this is a good change, I think this got introduced, and then they'll take it in. They may discuss it more over the mailing list, but fundamentally, this is how changes get made in 2002 to the Linux kernel. And what would happen is Linus would save this mail message to his local machine and run the patch command. Now, this is a lot of manual activity. There was no version control system here. There was Linus's source tree. That was it. And this is how patches get exchanged and discussed and iterated on. And that hit a scaling point. And that scaling point really stopped at around 2002, where this was just too much manual activity and they needed a system to help. And that's where this system called Bitkeeper came in. Bitkeeper was really the first distributed version control system, and what it allowed to happen was this mailing list system that Linus uses and Linus enjoys using, but it added a little rigor on top of it. Now, the problem with Bitkeeper was its license. It was a rather novel license at the time. The idea was that the company behind Bitkeeper charged for the software. It was a piece of proprietary software, and they gave the Linux kernel developers a free open source license of that. So they were free to use it. They didn't get the source code. It was not an open source project. But there were certain limitations. And one of those limitations was that they couldn't try to reverse engineer Bitkeeper, and they couldn't try to go compete and build a competing version control system to Bitkeeper as long as they were using it. And there was some tension between some of the kernel developers and the team behind Bitkeeper, and ultimately they decided that the Linux kernel should no longer use Bitkeeper, that it wouldn't be appropriate anymore. And so they set out finding a new version control system. Now, thankfully, in those 3 or so years since the Linux kernel started using Bitkeeper and the Linux kernel needed to stop using Bitkeeper, other people had really sort of seen the distributed version control system ideas and started productizing them. So you could see in 2005, Matt McCall, much like when Linus announced the Linux kernel on the Minix mailing list, Matt McCall comes to the Linux kernel mailing list and announces Mercurial, a minimal, scalable, distributed version control system. And he announces his early proof of concept, DVCS. It's very early on, but he's doing surprisingly well. Interestingly, in that message, he notes some of the things that remain to be done for Mercurial. That bottom one is what really interests me. All sorts of cleanup, packaging, documentation, and testing. This is a worse is better approach if ever I've seen one, and I love it. The funny thing to me, though, was the only response that he got on the Linux kernel mailing list is someone telling him that it was too worse is better. The first one and the last one are really important. If a tool is hard to use or poorly formatted, poorly documented, people won't use it no matter how great it is. And that is in direct opposition to the philosophy of worse is better. In fact, right? Again, we can put simplicity of user interface aside as long as the code is simple. And actually, the code in Mercurial is outstanding. Now, the other thing that happened in April 2005 was Linus making an announcement on the Linux kernel mailing list. And in the same understated way that he announced Linux, back in 91, he announced that he was writing some scripts to try to track things a whole lot faster. Really, he was focusing on just creating some scripts to help him manage the patches on the Linux kernel mailing list. He says that his scripts will not be an SCM, a source code management system, a version control system. They'll be a very specific kind of thing. Very interesting announcement. Very worse is better. It will never be a true SCM, a true version control system. It's just some scripts to help him out. So he's releasing this, announcing this early, even though it is not usable as a version control system. And that was the first version of Git. This is, if you run git log on the Git repository, you'll see this very early. This is the first revision of Git that was quote unquote self-hosting, meaning that Git was using Git. And that was April 7th, 2005. It's a long time ago. It's amazing how impactful and how long-lasting Git's dominance has been. Especially when you think about the fact that it was only a handful of files. You've got a make file and just a couple of C files. This is not a lot of code here. If you run, it's across everything, even including the README, it's it's almost 1,250 lines of code. That's not a lot. Now, was it complete? No. You could hardly do anything with it. At best, it's a mechanism for, it's a distributed file system. But, as Linus said, what it's not is a version control system. It's not an SCM. Was it consistent? No, not really. Was it correct? Marginally, yeah. It was mostly correct. It definitely had some interesting correctness issues, especially in its caching, and we can forgive that because we know that one of the hardest things in computer science is caching. But no, it was not completely correct. And was it simple to use? Absolutely not. You had to be Linus to use it. It was built for him, for his workflows. It was not built as a version control system, and it was, definitely not the Git that you see today. Despite that, people started using it. Now, of course, the Linux kernel hackers started using it because it simplified their lives in much the same way it simplified Linus's life. Like, their goal is to create patches for him to accept. His goal is to accept those patches. So these two things go hand in hand, and that is really what this system did. It did not resemble the Git that you use today. When you start thinking about, did it have a server? Was there a server-side component to this? The answer was no. And why not? Well, in the worse is better philosophy, why build your own server when Gmail can do it for you? So again, this is just patches over email, and we're going to offload the actual hard bits, the server part, to somebody else, and it's already written. We can just pick right up and go. Incredibly clever, and an incredible use of the worse is better philosophy. Very impressive. And was the goal satisfied? Like, did it get out there and get used? And the answer is yes. And people started not just using it with the Linux kernel, but people started using it with itself. Git itself was self-hosting in Git, and so Git's development started picking up. Right? So here's an example of somebody fixing a bug in Git and sending a patch off to the mailing list. And again, using Git to do that. So over time, Git started picking up steam, Git started picking up activity. People started using it, even though it was not simple in its interface. It was simple in its code, and that's what allowed it to be extended, but it's not easy to use. Now, as Tom Preston Warner said, Git makes collaboration possible, but it doesn't make it easy. In fact, it makes a very specific form of collaboration possible, this very distributed open source philosophy. Open source was much harder to develop for when really one person had the quote-unquote keys to the kingdom, or a few people had the ability to, write to the SVN server. Even if everybody could read it, it was still not a walled garden per se, but it was a very different experience to what we see today. And so Tom Preston Warner and several of his friends decided, well, if Git makes collaboration possible and doesn't make it easy, could they make it easy? Git's implementation is incredibly simple. It's elegant. It uses some really simple, straightforward data structures. And in fact, that makes it really easy to build on. And so, indeed they did. Tom Preston Warner, Chris Wanstroth, and PJ Hyatt built GitHub. GitHub.com launched in April of 2008. So a few years after Git's first revision, GitHub came with the ability to host public repositories and really easily send changes back and forth and discuss changes. Instead of knowing how to run the git format patch command and saving those files or understanding how to interact with your SMTP server from a command line, knowing which mail user agents you could actually trust to format your patches correctly and which ones would mangle them, knowing how to save those patches. That's incredibly tedious work. Now on GitHub, you open a pull request. You just push your code up to your fork, and you create a pull request on the main branch. It really lowered the barriers to collaboration on open source. It was revolutionary. The other really interesting thing, because Git is so simple in terms of its data structures, even if it's not simple to use, its code is very straightforward. Anybody who's really opened the internals book on the internals chapter to the Pro Git book will look at it. Even if you don't really know graph theory, even if you're not super familiar with data structures, if you really read the format and how these things are laid out, you'll quickly be very impressed by the simplicity of the data structures. And that allows people to build other things on top of Git. For example, also in March or April of 2008, Heroku added support for Git endpoints. So now you can just git push to Heroku to deploy your code. This is incredible. Like there's no tricky deployment options. There's no separate command line. You clone your code with Git, you hack on it, you commit it with Git, and now you can just run git push to deploy it. It was about this time that I think the world really started taking notice of Git in a very meaningful way. This was when Git went from another version control system that's in use to the version control system. The other thing that happened was we started seeing some command line clients on top of it. Because again, the worse is better philosophy says that the implementation should be simple. The interface doesn't need to be. And Git ships with a GUI. It's called GitK. And I don't even remember what's going on here. I mean, I do. I kind of know. You can see the graph, and that's kind of helpful to visualize. And you can kind of see a diff, and that's very helpful as well. But perhaps also not falling into the simple interface sort of category. But in 2008, 2009, we started to see some really new and really powerful user interfaces, some GUIs built on top of Git. You've got Tortoise Git, Source Tree, which was acquired by Atlassian, and then Tower, which is, one of the, I think, at its time was really the finest GUI. At this point, there are many fine GUIs, of course, but I think that this really showed a level of commitment to user interface that allowed Git to sort of reach the next level of popularity. So you've got all these things. You've got a totally new way to interact with your software developed by GitHub. You've got a totally new way to interact with your deployments by Heroku. And now you've got easy to use and simple interfaces built on top of Git. And it's that point that at least I, building competing version control systems, really started to take notice. And at the time I was working at Microsoft, I was working on the Team Foundation Server team. Team Foundation Server, if you're not familiar with it, it's now called Azure DevOps. It's a platform, it's a software development platform, so it's a bug tracker, it's got build and test, it's got version control built in. And in 2008, that version control tool was a custom version control system called Team Foundation Version Control. It was a centralized system that we built and that was one of the many version control systems on the market. But as we saw the Git ecosystem just growing and growing, and we saw these new sort of developments, we realized that perhaps building our own version control system felt kind of old school. We actually needed to sort of embrace Git. So in 2013, we released a version of Visual Studio that could speak to Git repositories, and we added Git support to Team Foundation Server. So now it could host both your Team Foundation version control, so the existing centralized system, and Git. We put Git into Team Foundation Server. And now this seems really obvious. Of course, Azure DevOps hosts Git repositories. What else would it do? It seems so silly to even mention it as if it could do anything else. But at the time, this was a big gamble for Microsoft, and it was actually tough for the Team Foundation Server team and the Visual Studio team to make this change. We were, in fact, starting to use a version control system that Linus Torvalds had built. And of course, Linus built the Linux kernel. A few years ago, there was some animosity between Microsoft and Linus, or at least the Windows team and Linux. And so it was not at all obvious that this was a good idea in the corporate experience that is Microsoft, to use a GPL software, the GNU public license, which various Microsoft executives have also historically had things to say about. It was not at all obvious that this was the right decision, but as you can see in 2021, 7-8 years later, it was the only decision we could have made as far as our survival goes. We simply couldn't have ignored Git and remained relevant. So, at that point in 2013, we really started to see things just continue to grow. And so now what we see is a really vibrant ecosystem. You've, of course, got Git itself, the Git command line application that Linus started and that Junio Hamano has maintained for years. Git is, of course, the core of the Git ecosystem. And then you've got other implementations that allow you to manage Git repositories in sort of a library, so that you can build applications on top of them, so that you don't have to shell out to Git and sort of screen scrape the output. JGit is a very popular one. The J is Java. It's a Java Git implementation. libgit2, that's the project that I maintain. It's a C implementation, and then there are many managed wrappers on top of that. So if you want to manage your Git repository with Python, you can, and there's a wrapper around libgit2 for Python. There are other various implementations. There's a new one in Rust called Git Oxide, which I think is really, really exciting. And so these sort of libraries and Git itself form the core that other tools can build on top of. Of course, you've got Git hosting providers like GitHub and many, many others. And you've got UI clients, that make using Git simpler. And of course, every IDE like Xcode and Visual Studio and VS Code speaks to Git now in 2021. Git won. There's just no way around it. And it won because it embraced the worse is better philosophy. It didn't worry about being complete, didn't worry about being correct necessarily. Obviously, nobody wants bugs in their code, but they didn't build a grand architecture and worry about over-indexing on that. No. Linus went and built a minimum viable product. He scratched his own itch, as we say in the open source world. He built a small set of tools that were simple, that had a simple implementation, and released them to the world. And now, it's hard to underestimate the impact of being Linus and having already been successful with the Linux kernel when he released Git. But had he built this grand vision and some sort of crazy microservices architecture, I don't think Git would have been nearly as successful and impactful and had this great ecosystem support that it has. Now, it's 2021. Every developer uses Git. Obviously, there are still other version control systems out there that have use in different aspects. For example, game developers have very bespoke needs. If you're writing a game like Grand Theft Auto, it has huge assets, movies, audio, still images and artwork, and Git does not do particularly well there. But even said, this is the minority. Most developers are using Git for most projects. I don't mean most like 60%, I mean most like 99%. So, how do you go from this dominance? Again, if there was a version control war, Git won it. What's next for Git? Well, I've got three things that I think that Git needs. Despite the fact that they've won, there are still three areas where Git falls short. First, support for large repositories. Like I said, the game studios of the world cannot use Git. There are some sort of workarounds and tools that will enable large repositories. First of all, there's GetLFS, or Git Large File Storage. And what this does is it's a third-party component that works alongside with Git, integrates really pretty well with Git, and allows you to set up a list of files that when you add them to your repository, they'll be sort of treated specially. And they'll, instead of going into the main Git repository, they'll go into the GetLFS area. And the advantage here is, if you've ever run a Git clone, what happens is you pull down every single version of every file that's ever been in your tree. And that allows you to look at history locally. It allows you to switch branches locally without ever talking to another server. It's exceptionally convenient. It's a great way to develop your code. It's a terrible thing if you have a lot of movies. If you're checking in, a 1 gigabyte movie, and you check it in, 10 different revisions, and you run git clone, you're downloading all those revisions. You're downloading all 10 gigabytes. GetLFS allows you to only focus on the files that you need at the particular version that you're checking out. So it's very efficient, but it only integrates so well. It's not really part of Git. It's a third-party tool that you have to download and install. You have to configure your repository very carefully in order to make sure that you're using it. And it's not retroactive. You can't take a repository where you've checked in a bunch of movies, add GetLFS, and then win. No, you've actually got to rewrite history or actually change that the way that things have been checked in historically. So it's not perfect. It's great. It's a big help, but users, I think, require a little more simplicity. There's another tool that a team at Microsoft built. They're now at GitHub. It's called Scalar. And the goal behind Scalar was, again, supporting large repositories. The Microsoft Windows repository and the Microsoft Office repository are two incredibly large chunks of code, both in terms of what's there just on disk, what you need to check out and build in order to ship. Remember, Windows fits on a DVD. It doesn't fit on CDs anymore. Same with Office. And so, not only the tools that get built, the code that gets built, but also the history, right? If you've got this giant repository that, when built, fits on a DVD, and you need to, and you're making changes to it, that's a lot of history. And so the goal behind Scalar is to address this and start thinking about actually in Git itself, downloading only the pieces that you need at any one point in time. So in other words, when you run a clone, maybe you just get the most recent version and you can start paging in those older versions dynamically. So it's a bit of a hybrid model almost between a distributed version control system where you've got all of your history and a centralized system where the server has everything and you go get it. Now, this is bringing a little bit more centralized philosophy on demand when, as an opt-in approach to Git. Most people won't need this, but the people that do need it really need it. And I think that seeing these sorts of improvements going into Git itself, so that they're not standalone programs, so that they're not, third-party add-ons, I think is going to be crucial for, the next few years of Git. The other thing that I personally would like to see in Git for what's next is better cross-platform support. Now, it's understandable in many ways, but Git works best on Linux. Git was built to manage the Linux kernel's development. No surprise, it works best on Linux. A lot of the people who are Linux kernel hackers, including the person who started Git, were very active in Git's development. And so what happened was you'll see things like, yes, Git is a lot of portable C code, but there's also Perl scripts and shell scripts and TickleTK, which, if you're not familiar with, is a older programming language and windowing system that was common on Unix systems, not very common on Windows. So there is a Git for Windows project, of course, and it's managed by volunteers who do an incredible job porting Git to Windows. And that is hard because, again, there's Perl and shell scripts in Git. So when you download Git for Windows, you don't just get an executable that is git.exe. You get a whole Unix-like environment. So the MinGW system, which is a minimal Unix-like environment on top of Windows, is downloaded every time you download it, Git for Windows. So that's why you see Git Bash, for example, because it's not because the maintainer of Git for Windows really thinks that you should be using Bash to interact with Git. Maybe he does think that. I actually don't know. I've never asked him. But the reason is a lot simpler. It's that you need Bash because you need to run these shell scripts, and you need to be able to actually have all of the various Unix utilities like cut and awk and sed that go along with having shell scripts. So when you download Git for Windows, you really get a Unix-like environment that gets installed. And that, in a perfect world, wouldn't be a requirement. Maybe it's optional, right? Maybe at this point, users of Git for Windows are so enamored with the Unix-like system that they want to keep this. That's fine, but it shouldn't be a requirement. So the Git for Windows team has been rewriting many pieces of Git in C, in portable C, so that they can remove some of the dependencies on shell scripts. I think that will continue, and I think that that's an important goal. Finally, making Git easier to use. We've seen definitely some improvements in Git's ease of use over the last few years. Obviously, it's very early incarnation. It was not easy to use at all, but there was a point at which it became a full-fledged version control system, and yet it was still very difficult to use. You know, the reset command does many different things depending on how it's invoked. The checkout command does many things depending on how it's invoked. It might get the old contents of a file and replace the contents as they exist on disk with some historic version. Or it may switch branches. Like, those are two very different concepts for one command to do. It may create a new branch. That's at least kind of close to one of those two things, but like these are very different core concepts that the checkout command is operating on. And so you've seen some improvements, especially around reverting changes. And I hope, I believe that we will continue to see more, because we can't rely on third parties and GUIs to really do this. I think that Git itself, the Git command line client, has to be capable of simplicity in its interface at this point. It's had simplicity in its implementation from day one. I hope that we'll see continued efforts to simplify its interface. If not, I trust that somebody else will do it. In Linus's early announcement of Git, he said, well, I bet you could make a reasonable source code management on top of it, though. So hopefully somebody will. Just kidding, of course. I'm confident that the Git team itself will take care of this for us. Thanks so much for your time. I'm super happy to be a part of GitKon. I hope that you are too. If you have any questions, if you have any comments, please hit me up. The best way to reach me is on Twitter. I'm eThomson. That's Thompson without a P, ETHOMSON. And I look forward to hearing from you.
All right. And we have here Ed Thomson for our live Q&A session. Ed, that was wonderful. Welcome to the live Q&A.
Thanks. It's great to be here.
Yeah. So we have a lively Discord channel going on. We have a few questions from the Discord. So first up, we have one from David, who is asking, will Git integration be embedded in most apps and not just for devs? Is there a way to track how many apps use libgit2?
That's a great question. Yes, I think we will see Git integration start to be integrated beyond just developers. I think that it's a handy way to store versions of things, especially versions of text-like things. And so, I know a startup that was building some sort of proof of work, not proof of work in terms of. Sorry, let me back that up. That makes it sound like I'm talking about blockchain. Some sort of verifiable and auditable trail for documents on top of using a Git database and using libgit2 to do it. And so there are certain places where that makes sense. Git as a generic database, I don't think actually really makes a lot of sense a lot of the time. I think a lot of people look at it and are like, oh, this is going to be great, and then really quickly realize that it's not great because they hit some scaling dimension that most people's code just doesn't hit. But yeah, despite that, I think that we'll see more of that. I know of especially like tools that are adjacent to development but not strictly for version control, I think makes a lot of sense. I know another company who was storing, a version controlled sort of database of not code, but and they wanted to be able to roll back and view history, and it's like, well, that sounds like Git to me, and so they're moving away from a proprietary format to Git, which I think makes a ton of sense. As to the second question, is there any way to see how much libgit2 is in use? I wish there were. That would be so helpful for me. I find it really hard to track, and sometimes I see a new announcement of a Git tool, and I'm like, oh, I wonder how they're doing it. And so, oh, they're using libgit2. Oh, that's great. I'm really excited to see that. But it's really hard for me to know. The easiest way for me to track it is the people who show up in our repository and either ask a question or contribute code back. That's how I found out that this tool called Git Kraken was starting to use libgit2. And I've seen other people's, recently I found out that one of the math programs, I know that Mathematica has been using libgit2. I happen to be pretty well connected to that organization, and so I kind of knew that, like for version control, or they have an interface where you can talk to Git from Mathematica code, which is really clever, I think. And so, yeah, it's great to see. I wish I had a better way to find out who was using it, but.
Well, you gave me a good segue earlier. You used a nice keyword here. So someone was asking if you can touch on the connection between Git and blockchain.
I can't. I know nothing about blockchain.
Yeah, it's good to know. I know there's been that was a fun topic to discuss in the Discord yesterday. So just not to poke your brain there.
I think that's where I've learned. I think I learned more about blockchain yesterday than I have previously.
Wow.
Yeah, I mean, my understanding is that there are some similar characteristics, but Git's historical roots go back to Merkle trees and directed acyclic graphs, and it's not super cutting edge. So it's just simple data structures applied in a clever way.
Next up, we have a question from William, or Nexus, as he is famously known. What is the easiest way to test libgit2 to be able to help contribute?
The easiest way, I think, and I guess this isn't generally available yet, but one of the things that I've started playing with is GitHub code spaces. It's basically an IDE in a browser. It's a partnership between GitHub and the Visual Studio Code team. This sounds like a big plug, and I guess it kind of is, but I don't mean it to be. I actually really do love this. I think that it's insanely clever. And so, you can just start up a code space, and I've checked in a bunch of, getting started and dot files and stuff, so that if you do have access to code spaces, it's really easy to get started at libgit2. It just as soon as you click start, it just bootstraps your environment. It does your first build, and you're ready to just start hacking. You can even hit debug in code spaces, and you can start stepping through functions. It's so cool. By far the easiest way. I mean, second easiest is to take all that, clone it, and do it in VS Code locally, because it's the same setup. But who wants? It's 2021. I'm starting to get tired of cloning things to my local hard drive and running tests locally. It's getting a little tedious.
Next up, we have a couple comments. So they're more comments, not necessarily questions. The first one, just kind of a little bit of a praise here. Just fascinated by the history that you presented during your keynote session. What's it been like just to watch this Git evolve, or even just before Git, like BG, I think was what you called it, to kind of see that evolution over time?
It's mind-blowing. I mean, like I said, I used to work on version control systems. My very first version control job, I guess, was working on a tool called Source Offsite, which was an add-on to Microsoft Visual SourceSafe, which was extremely popular, despite the fact that it was extremely poor. Like, one of its defining characteristics was that it would frequently corrupt itself and its database. Yeah, it was not good. Source off site basically was a wrapper on top that would fix the corruption problems. And so, that was an add-on to a popular but not like revolutionary or the most popular version control system. And so being able to go from that to working on Git has just, it's been incredible. I never could have imagined that we would have a dominant version control system and that it would be it would be like this. So it's just been really fascinating to watch this history. I too am fascinated by the history. I've enjoyed every minute of it.
And with the history, so you talk about from before Git and then as it evolved, and now we're here at the present. What do you see about the other side of things? How do you see it evolving from here?
I really do hope that we finally, I'm glad that Git GUIs exist that make Git easy to use, but we're not there yet, in my opinion. I'm a command line person, and I feel like I would really strongly benefit from some nice command line features. I thought it was really interesting. I didn't actually know that that Git Kraken was going to announce the CLI that they did, and so that's pretty compelling. That may be the thing that finally bridges the gap for me between using a third-party Git tool and the CLI, because I just don't love lots of windows. I know I'm just ancient, but it's still true. And so this may be the thing that finally does it.
Yeah, that release just dropped a couple days ago, so definitely check it out, especially those who are watching either in the present or in the future on YouTube. Definitely check it out. Maybe we'll change your mind. I'd be curious to hear all y'all's thoughts. We have a feedback in the top right. Another comment we got, I know you were mentioning Linus over there and how he casually or subtly, without much pomp and circumstance, would announce these major, huge, revolutionary tools. But love the typo that Linus Torvalds had. Looks like he wrote prodible instead of portable. That was big there.
Yep, I noticed that too. I had a lot of fun putting this together and just like going back and unearthing all these old emails and news group posts. I even the talk that I referenced repeatedly, which worse is better. I actually first read in this book, the Unix Haters Handbook, which is an outstanding book.
Wow.
However, it's from 1994. This was not my original copy. It didn't survive. I had to go buy this on eBay. And so there are still some copies in pretty decent condition if this is, ancient Unix history is something you enjoy.
It just goes to show, I think this comment kind of captures a little bit of the core of your talk, where it's okay to put something out there that is not perfect, right? Even something like a description, don't worry about it. Just get it out there in front of people and keep iterating.
It's true.
So I want to close out and maybe give you an opportunity to share any final thoughts.
Oh, I think you did. I think that you nailed it. It's we often, a term that we use at GitHub is we get wrapped around the axle, and it's really easy in software to just get so caught up in in all the bugs that exist in your code, because they exist, of course they exist, and all the features that you don't have yet, and it's really easy to just find that North Star and just start hacking and not come up for air until you think you're there, but you're never there.
Yeah.
You just got to ship. So that's one of the tricky things is figuring out when it makes sense to just get it out there versus the right set of bugs and features. But I often think that we're too conservative and we don't and that doesn't benefit us.
I think it's an important sentiment to hear. I know for sure that's a relatable sentiment where you because you know what's behind the curtain, you see all these things that you wish you could build or wish you could fix, and just to hear from an outside person like, hey, you're actually doing pretty good, and like you don't have to worry, you don't have to sweat the small stuff too much. Well, the other stuff too much, I should say. Yeah. Well, Ed, I think we can leave it at that. Thank you so much. It's been a pleasure to have you keynote our day 2 session, and looking forward to seeing you on the Discord if you can keep us company there. And thank you so much.
No, thank you. It's been great to be here. I'm really excited about the first GitKon.